Hello everyone, I'm Abhinaya from CSCA in the ML second year. Now I'm going to discuss the answers for RECode conducted by Coding Club. The first question is, um, we are given with a linked list and its head is given as an input. We need to double the input. The number represented by the linked list should be multiplied by 2, and it is again the answer should be represented as the linked list. We need to written the head of the linked list as per the problem. Um, since the input is here, the first line of the input is 3 and the second line of the input is given as the numbers. We are not actually dealing with the pointers in the input and output, but inside the function we are actually dealing with the linked list. So let me explain it. The first line of the input here represents the number of nodes the linked list is going to contain. Here the number of nodes is actually 3, and the second line of the input is essentially the numbers inside the linked list, and as stated, each node of the linked list is going to contain a single digit number. That is obvious from this. And if you multiply 189 by 2, the answer would be 378, and that is what is given as the output, 3, 7, and 8. We need not give the output as the head of the linked list. We need to essentially print each and every number stored in the nodes of the linked list. So this is our intention. Now I have explained the input format and how the output should be. In the main function, I'm just getting the input n from the console, and I'm creating head, tail pointers. This is essentially to represent the numbers given in the input console as a linked list. Only then we can perform operations in the linked list, because barely with numbers we cannot manipulate. The intention is to store the given numbers in the linked list in each node of the linked list, and then we need to manipulate. Finally, we need to give the twice of the number. For that, I have initialized my head and tail pointer as null. For those who do not know what a linked list is, it is nothing but a sequence of nodes which contains two parts. Here we are considering only the singly linked list with one data part and one next part. For example, I could say this is for how a linked list would look like. Um, these are the sequence of nodes. If you consider a single node, it will contain two partitions if it is a simple linked list. The first partition would contain the data part, and the second partition would contain the address of the next data point. So, for those who do not know what a linked list is, this is the basic thing you need to know to understand this concept. I have essentially stored the input given in the input console as a linked list. So this is what the code for that. Next, I am defining the structure of the node. As stated earlier, a node contains two parts. The first part should contain the actual value, which is an integer. The second part should contain the address of the next node. So I am storing it as a pointer variable that points to another node. So I have defined the structure. And then for getting new nodes, I have defined this particular function which calls malloc, that gets the node from the memory, this malloc function, and all the other manipulations I have done. The given value should be stored as the value of the node, and the next should be given as null. And after that, the linkages should happen that I have given in the next part. And I have defined the display function so that the output can be displayed. So the actual routine goes here. First, let me explain the tracing of the code, and then I will come to the actual code. Here I have made the tracing. I have taken an example as 9, 9, and 9. This is how they should be internally represented in our code. Okay. First, I have made a head pointer to point to the first node, and I have assigned a temporary pointers as T1 and T2. Here I have given temp1 and temp2 for simpler manipulation. I have given it as T1 and T2 here. So essentially we need to multiply the number into 2. So I'm I'm starting from the first node. I have multiplied it into 2 and stored the value there. It has become 9 has become 18 here. One more thing we need to consider is a node can contain only single digit values, so that uh, our intention can be satisfied, right? So for that I'm taking the modulus of the function, and in order to store this particular number 1, I need a new node. So for that I'm checking the condition if and only if the temp value that we have manipulated after multiplying by 2, if it exceeds 10, I should go for this particular routine, or else if it is a single digit we can leave as such. But here it has exceeded the value 10 and it has become a double digit number, so we are in need of a new node that could store the additional digit. So I'm getting the new node and making all the manipulations to link this particular new node with our existing linked list. I'm making the connections as, let the new node's next part, the address part, be pointed to the head of the present linked list, so that it can be linked as a single linked list. Okay. Now I need to split these two digits. For that I'm calling the modulus function, and the remainder part is stored in the present head, and the new node is stored with the value 1, because we know the excess digit will always be 1. It can never exceed 1, because since all are single digit numbers, the maximum single digit number that the input linked list can hold is 9. The twice of 9 will be obviously 18. If we have stored 8 in the present node, and the remaining digit, that the preceding digit will always be 1, that is guaranteed. So we have directly given the new node val is equal to 1. Now my head should point to the new node created, only then the sequence can be read as such. So I have made this particular manipulation, head is equal to new node, and this should not be stopped here. I need to double the remaining numbers too. For that I have made this particular thing. Here I have defined something, I'm calling this routine until temp2 is not null. It means that temp2 here initially it is pointing to head of next. It means that um, there is some node existing after the head node. So as far as this holds true, this manipulation should take place. So I'm multiplying the once these two things are over, I'm going to the next node, checking for temp2. Once temp2 is not empty, it is found not empty, I am placing the twice of that particular number in the same node. Since it exceeded 10, it means that it has become a two-digit number. I need to split the digits. After splitting the digits, the x digit should be added to the previous node. For that, I have made this thing. Temp1 is the previous node of temp2. So the remaining digit is being added here. I'm taking the remaining digit by dividing the number by 10, so that I can get the quotient and it is added to the previous node. So it is continued for the rest of the thing. So when I run this code, I have got the test cases passed. Okay, the second question is Kruskals algorithm, and it uses the concept of Manhattan distance. Here it is given Manhattan distance is nothing but when two points are given in coordinate form in two dimensions. So it is by x coordinate and y coordinate. The difference between the absolute difference between x coordinates and the absolute difference between the y coordinates, when they are added together, that will give the Manhattan distance. So it is essentially like this. If you consider this as a particular node, and this is represented by a coordinate, and this as an another node, this is given by an another coordinate, represented by another coordinate. If you can use Manhattan distance formula, you can find the distance between the things. So if and only if the distance is found, we can find the minimum distance of the spanning tree. It is given as spanning tree, so let me tell what the spanning tree is. If you consider this to be a particular graph, this is closed and it is undirected. If you want to generate a spanning tree is essentially it's like a graph. It is going to be undirected, but it is also going to be acyclic. It should not form any cycle within itself. At the same time, it should generate a path considering all the nodes in it. It should not leave out any of the nodes. That is one of the intention. Okay, we are going to use the Kruskals algorithm. The Kruskal algorithm um, starts with arranging the weights in ascending order and then finding the cumulative distance from the source to destination. So let me explain. This main function is essentially getting the input from the console and storing them. So n is, I'm taking an example. So n here is given as 3. So it has 3 rows. It is going to have 3 rows. And I'm storing the values given as coordinates in the points array. I have declared the points array as global so that it is visible to all the remaining functions. So I have made the column as 2. It means that we are going to have only 2 coordinates, but the number of rows is what is going to be deferred. So I'm getting all these things. So if I take an example, this is how it is stored in the points array. And then Kruskals algorithm is called. Here is the Kruskals algorithm. So I'm going to have the edge count. It means that how many number of edges I'm going to have, and in the edges, I'm going to store the value of the path. It means a value of the edge. So it means that when one node is connected with another node, what is the distance of that particular edge? So that is being stored in this edges. I have made the columns as 3. So it means that it will be somewhat like this. It means that when I connect the 0 and 1, the cost is 12. So 0 and 1 is connected, the cost is 12. 0 and 2 is connected, 0 and 2 is connected here, and the cost is 18. How it is calculated, this particular distance, it is using the Manhattan distance. I have defined the Manhattan distance here. What is that exact formula given in our problem statement? I have used it here. So that Manhattan function is called here and it is stored in the last row of edges. So this is how, and as I told, we need to first sort the edges in ascending order. So this particular function sorts the edges in ascending order and gives. So we are going to cumulatively add the edges together. First, I would take source as the first edge essentially, and then the destination as the next nearest node. If I would take that, we are actually calling the find function here, which is going to find the next shortest distance it could find. When that is found, we are cumulatively adding the total cost, and in the union function, what is the actual source set I have now at present, to that the destination set that is found in this routine is also added, so that a complete path is generated, and then finally I'm printing the total cost of it. So this cost is the distance that is covered. So here, if we have taken this particular example, the Manhattan distance is computed like this. After sorting, it would be like 6, 12, and then 18. So if I would consider in the sorting order, 6 and 12 is considered, and this itself um, encompasses all the nodes, and a spanning tree is generated. If I could add these two things, 12 plus 6, it gives me 18, and this is the minimum possible cost that the spanning tree can have. Because if you could add 12 plus 18, it is greater. If you could add 18 plus 6, it is also greater. So 12 plus 6 is the minimum distance that it can have. So when I run this code, here also the test cases get passed. So hope you have understood. Thank you for listening.